students, now we are going to see the dimensions of means the limitations of the dimension analysis. That we have few limitations. That what are those? Let's see. So basically the first limitation is that it supplies no information about the constants. Now when I ask you what are the constants basically, so as I've seen, as I've shown you that when we were using that last relation, that is time period, that was basically 2 pi under root L by G. But the limitation of dimensions is that we cannot find that constant, right? What is that? So that's the limitation. And the nature of physical quantities means using dimensions, you cannot say whether it is a vector or a scalar. So that is again a major limitation of dimension analysis. And second is, this method fails to derive the exact form of physical relation. That is, if a physical quantity depends on more than 3 other physical quantities. Let's say if we have, because what we are doing, we are writing in terms of m, l and t, that is the mass, length and time. So basically if there are more than 3 other physical quantities, means up to 3 we can use this, we can find it out. But if there is some expression which depends on more than 3 quantities, so that's again a limitation, that you cannot find such relations using dimension analysis, right? And the third is, this method is applicable only in the case of power functions. Like there has to be something in terms of powers, right? It fails in the case of exponential and trigonometric relations. Means it does not work for let's say if there is some relation where we have the terms of e to the power x or a trigonometric function, so that's, in that case you cannot work with dimensions, right? So these are the major limitations. Now we have a quickly move to a question. Now what does the question says? That if force F, length L, current I and time T are taken as fundamental dimensions, then the dimension of permittivity epsilon naught r is going to be what? So basically these are the 4 options. Now if I ask you what is the basic concept based on the permittivity? Now if we say when we talk about permittivity, that means what? Basically we know that force is equals to what? Coulomb's law. So that is force equals to 1 upon 4 pi epsilon naught Q1 Q2 by R square, right? So from here we'll have the epsilon naught as what? 1 upon 4 pi Q1. Now what is Q1? Q1 is charge, and charge is basically we know the definition of current, that is flow of charge per unit time. So this charge can be written as what? Current into time, and unit of current is what? Ampere. So we'll have ampere into time, and since it's Q1 Q2, so we'll have AT square, right? And then we have what? R. So R is going to be basically a distance, so in distance will be expressed in terms of L, right? So we'll have L square. And then we have what? Force. Now basically the fundamental units, if we say we have the term as force, so simply we can write this as what? We can write this as F. So from here we can get the dimensions of epsilon naught, that is going to be what? F minus of 1 A square L to the power minus 2 and T to the power 2. So this is going to be basically the dimensions of what? Permittivity. So let's see which option is correct. F minus 1, right? And basically the current, they have not represented by ampere, they have represented by I. So no issues. Will take in place of A, what we can do? We can take the value of A as I. So we have what? F minus 1 I square L minus 2 and T 2. So we have F minus 1 I square L minus 2 T2. So I guess C is going to be the correct option. Fine. So let's move further. Now we have a term called order of magnitudes. Now let's say if we are giving some magnitudes, so definitely we are expressing in terms of powers of 10, right? Let's take an example. Suppose what is the standard condition that the decimal is to be used after the first digit, and then we use the powers of 10. Now that's the standard, right? If I ask you the speed of light, what it is? 3 into 10 to the power 8 meter per second, right? If I ask you mass of proton. So what is that? 1.67 into 10 to the power minus of 27 kg. So basically what we are doing, we are representing any physical quantity or anything in basically a numerical form, right? Where the decimal is after the first digit. So you can see that after 1 we have the decimal, right? And then we have 10 to the power what? Minus of 27. So basically you are expressing in the powers of 10. Now that's the standard, right? So these are the examples. Let's say if we have given 3750 means 3750 meter. Now basically we have to write it in the scientific notation form, that is there should be a decimal. So how we do that? See, let's say we have 3750, right? That's in meter. Now we want to bring the decimal to this place, that is after 3 we want decimal. So what we'll do, how many digits are there after 3? 3 digits. So we'll divide it by 1000, right? Now if we are divided, then obviously we have to multiply as well. So we'll multiply it by 1000. 1000 means 10 to the power what? 3. Now simply you can cancel the zeros and you can put the decimal. So you have the answer is what? 3.750 into 10 to the power 3. Now that's the standard notation to represent any quantities, right? Then we have an important topic, that is your significant figures, right? Now what is significant figures? Why do we use them? Let's understand, right? So basically each of the digit of the number, means we have a certain number, then we have to basically we are using this to express it to the required degree of accuracy starting from its first non-zero digits. Basically we want to represent any number, whatever the number is, it should start with some non-zero digits and up to what accuracy it is. So we have to basically see that, right? So what do we have? We have the rules for the significant figure, and the first is to determine the number of significant figures in a number. Means whatever the number we have to basically show how many significant numbers are there, right? So we'll move further. What do we have? Non-zero digits are always significant. Let's say if I ask you 345. So these are all non-zero digits. So if I ask you in this number, how many significant figures are there? So in this number, we have 3 significant figures, because the what is rule number 1 says that all non-zero digits, means which are not zero, are counted as significant. So 3, 4, 5 in total we have 3 digits. So all the 3 are significant, right? Then second rule, any zeros between 2 significant digits are significant. Like let's say if I have 1002. So basically these are the zeros which are coming between 2 significant digits, because these are non-zero digits, and as we have studied in rule number 1 that the non-zero digits are counted as significant. So if the zeros are in between 2 non-significant digits, they are also counted as significant. So basically what does it mean? This means that this has in total 4 significant figure, 1, 2 zeros and 1 2. So in total we have how many significant figures? 4 significant figures. I hope rule number 2 is clear. Then we have rule number 3, a final zero or a trailing zero in the decimal point, in the decimal portion only are significant. That is, if we have final zeros or trailing zeros in the decimal portion, let's say if I'm saying we have 25.700. So basically these zeros are in which portion? Decimal portion, right? So these are trailing zeros also. Why trailing? Because they are at the end. So they are counted as significant. So if I ask you the significant figures of this, so it is going to be basically your 5. I hope it is clear. Now we have the examples of this, that is 0.500 or 0.632000. The zeros are significant, and 0.006 or 0.00968, the zeros are not significant, because these are not trailing zeros. These are in the decimal portion, but they are not at the end. They are at the beginning, so they will not be counted as significant. So these have the zeros and they are significant because these are basically your trailing zeros, right? But these are not trailing, these are at start. So they will not be counted as significant, right? Let's move further. So we have, for additions and subtraction, we have certain points, that is to count the number of significant figures in the decimal portion only of each number in the problem. Means whatever the number we have, so we have to basically count those, right? Then the rule number 2, add or subtract in the normal fashion. Means whatever the number we have, you can simply add in the normal fashion. What do you do exactly, right? Then your final answer may have more significant figures to the right of the decimal than the least number of significant figures in any number in the problem. Means whatever the question is, it may be possible that after adding or subtracting, you have more number of significant figures or less number of significant figures than the actually what we have in the problem, right? So we'll see an example based on this. Now, what does the example says? We have 12.439, 9.375 and 15.7. These are the basically three numbers, right? Now, once we add them, that is, you add them, you have 37.514. So you can see that in this, how many significant figures are there? 5. In this one, we have 4. In this one, we have 3. But at the final answer, we have how many significant figures? 5. So that's the rule of it. I hope you understood. Now we have question based on this. Now what does the question says? Basically, what is the sum of 7.9, 19 and 5.654 taking into account significant digits? So simply what we are supposed to do, we are going to take these three numbers. That is, what are those? We'll note it down first. We have 7.9, right? Then we have what? 19. So this can be written as simply 19.000, right? Here we can write 2 zeros, right? Then we have what? 5.654. Just simply add them. So you'll have 4, this you'll have 5, this you are going to have 15 decimal, 1 will be the carryover, and then you have 9, 10, 17, 5, 22. So your final will be 32.554. So that's going to be your number, right? And in this number, how many significant figures we have? We have in total 5 significant figures, right? So that's the end of this question. I hope you understood. Now we have for multiplications and divisions also we have certain rules. Now what is that? The least number of significant figures in any number of the problem determines the number of significant figures in the answer. Means, let's say if we have the answer, so basically the least number of significant figures we'll be using in our final answer, right? So we'll have that's an important example. We have 3.9898. If I ask you how many significant figures it does have, so you can count them simply. We have almost 5, right? And when I say in this one, if I ask you that how many significant figures are there, so after the decimal we have 2 digits, so we have in total 2 significant figures. So once you multiply this, obviously this will be your reported answer, right? But as I said, the rule says what? That the number of significant figures in final answer should be the least number of significant figures in the question. So in question we have how many least significant figures? We have 2 least significant figures. So what we are supposed to do? We are supposed to express it up to 2 decimal place. Now for that we have to understand the concept of rounding off. We'll explain it in detail. But what is the simplest process? That whether this number will be taken as it is or this will be increased by 1, that depends on the number which appears to the next place. So the number which is appearing onto the next place is your 7. Now if it is greater than 5, right? Let's say if it is 6, 7, 8, 9, that is in this case you can see it is 7. So you'll just increase it by 1. So you'll have the final answer as what? 0.92. So that's the way of solving such type of multiplication problem. I hope you understood. Now we have question, that is 19.3 multiplied by what? 26.12, and we have to take it into account the significant rule. So basically simply first we'll multiply 2612 with what? 193, right? So we have what? 326, 3 ones are 3, 3 6 are 18, then we have carryover, then we have 7, right? Then 9 2s are 18, simply 1, 10, then we have 9 6 are 54 and 155, then we have the carryover as 5. So 9 2s are 18 plus 5 is what? 23. Then we'll put 2 cross, then we'll have simple, that is 2162, right? So you add them, so you'll have 6, 11, again 11, So we have 504116. Now if I ask you what was the decimal position, so we have in this here and this we have here. So in total we have up to 3 decimal, means 3 digit before we have to apply the decimal. So we have 504.116. Now if I ask you the least significant digits in this are how many? In this we have 3, right? And in this one we have basically 4. So our final answer should contain how many significant digits? It should contain 3 significant digits. So basically if we say the answer, this have how many? 6. So basically we'll take up to 3. So definitely we'll take 504, right? And these are the first 3 significant, because the non-zero digit between the two, 0 between the 2 non-zero digit will be counted as significant. So simply 504, and the digit which is coming after the decimal, it is 1. So you can take this number as it is. So you'll have the final answer as what? 504. I hope you understood. Now we have rounding off. Now that's an important concept, that is we have to basically round off, right? So there are again, as you have seen in significant figures, there were some rules. So in rounding off also we have certain rules applicable to it, right? So first is, in rounding off, the numbers, the last figure kept should be unchanged if the first figure dropped is less than 5. Means whatever you are dropping, so if it is less than 5, then the first figure should be unchanged. Let's say we have an example that is 6.422, right? And if you want only 1 decimal is to be kept, then means after the decimal if you want 1 digit only, so this is the dropping number, right? And if it is less than 5, then the number previous to this, that will be as it is. So your final answer would be simply 6.4, right? Now the rule number 2 is that in the rounding of numbers, the last figure kept should be increased by 1, right? If the first figure dropped is greater than 5, means whatever the number you are dropping, if it is greater than 5, then you have to increase it by 1, right? So you have an example for this. See, you have basically if you want only 2 decimals, means after the decimal you want 2 digits. So you have the number as 6.997. So you want 2, so this has to be dropped. And now if this one is greater than 5, so you have to increase the previous one by 1. So you'll increase the 9 by 1, so you'll have to write it as 10. So 1 will be given to the carryover. So again you'll have 10. So ultimately this will be rounded off to 7.00, right? So that's the rule number 2, right? Then we have, in rounding of numbers, if the first figure dropped is 5 and all the figures following the 5 are 0, or if there are no figures after the 5, then the last figure kept should be unchanged if that last figure is even. Now what does this say? We'll understand by an example. So we have the example of 6.6500. So you can see that how many digits we want after the decimal? We want 1 decimal, right? That means simple rule is that if you want 1 decimal, so this has to be dropped. Now this is not less than 5, this is not greater than 5. You can see this is equal to 5. Now if it is equal to 5, what does the rule says? That if this is the last digit or we have the zeros ending to it, then basically this digit has to be unchanged. So if this is unchanged as per the rule, so simply we'll take the number as 6.6 as it is, right? So I hope you understood this rule as well. Then we have another example of this. Let's say we have to want 2 decimals, right? So again, because there was another possibility that the last figure is even, then also it is unchanged. So see, we want 2 decimal, so this digit has to be dropped. Now it is not less than 5, it is not greater than 5. So what do? We have the digit before it is your even number. So if that is the case, if that's an even number, you will keep as it is. So you'll have simply 7.48, right? Now we have another rule. If rounding of number, if the first figure dropped is 5 and the figures following the 5 are 0, or if there are no figures after the 5, then the last figure cap should be increased by 1 if that last figure is odd. Now that's the case of odd. We'll see it by an example. So see, we have what? 6.755. Now how many decimals we want? We want 2 decimals. So this is the dropping number, right? And after that we have what? Trailing zeros, right? Now number before this is an odd. So if that's an odd case, means if it's not an even, so you have to increase it by 1. So you have to increase this 5 by 1. So that becomes what? 5 plus 1. So that will be equals to what? 6. So you'll have the answer as what? 6.76. Now we'll move further. We have another example. Let's say we have 8.995. Now we want how many decimals? Means after the decimal, how many? We want 2 digits. So that has to be your dropping number. Now that is equals to 5. Now what you are supposed to do, if this is 5, then we'll see the number before this. So that's an odd number. So you have to increase by 1. So when you increase by 9 by 1, so you'll have simply 9 plus 1, which will be what? 10. So this 1 goes to an carryover. Then again we'll have 9 plus 1. So we'll have 10. So again 1 will be passed to 8. So we'll have 9.00 as your final answer. I hope you understood well. Now we have, in rounding of the number, is first figure dropped is 5, and there are any figures following the 5 that are not 0. Then the last figure kept should be increased by 1. Now what does the rule says? We'll understand by an example. See, we have 6.6501, right? And we want only 1 decimal. So this has to be your dropping number, right? Now rule says that the after that 5, the numbers are not 0. Then the last figure kept should be increased by 1. So that was the last figure, right? And this has to be increased by 1. So you'll add 6 with 1. So you'll have what? 7. So your simple answer would be what? 6.7, because you want 1 digit after the decimal, right? So that's an important rule. We have another example. Let's say we have 7.485, and if you want 2 decimal, means we want 2 digits after the decimal. So basically this is going to be your dropping number. That's again 5, right? Now if I ask you that these are the digits which are non-zero, and the digit which is appearing before it, that has to be increased by 1. So you'll have simply 1 plus 8. So that goes to your 9. So you'll have the answer as what? Simply 7.49. So I hope it is clear to you.